So our next section is going to be on implicit differentiation. Okay, so we're going to talk about how to differentiate if my function is written implicitly versus explicit. Okay, so this is 3.5. I've just got it down a little bit. So just very quickly going back, explicit functions, all that means is they are of the form y equals. So it's f of x equals or y equals. That's what we've done so far. So all of the derivatives that we have found have all been of the form f of x equals or y equals. And we can apply all of the rules. Now we're going to look at what if the function's not y equals. That's called implicit. Okay, a function is written implicitly, or it's called an implicit function if it's not of the form y equals. Now sometimes you can just solve for y, like the first one I could just divide by 2 and solve for y. The second and third, these two examples, I cannot solve for y. So I have to find the derivative using this method, which is implicit differentiation. Okay, the idea is you're going to just differentiate the equation with respect to x, and then solve the resulting equation for y prime. Okay, so all that means is now, just like before, when we went and found the derivative of an equation that was y equals, the derivative of y is y prime. Okay, so we know that the derivative of y here would be y prime equals, well, same thing. So now when the y is inside the problem, when I get to any part of the equation that has a y, the derivative of y will be y prime. So now I'm just going to actually have y primes in my problem. Let me get to doing some examples to show you what I mean. Okay, so first example is x squared plus y squared equals 25, and I want to find the derivative. So I am going to get my pen and and find the derivative of this. So the derivative of x squared is 2x. Okay, so that's fine. When I get to the y squared, the derivative of y squared, the outer would be the squared, so it's just like normal, 2y. And then what's the derivative of y? Y prime. So again, whenever I have a y in the problem, I'm going to apply the chain rule and have a y prime, and the derivative of 25 is 0. And now you would solve for y prime. There's only one in the problem, so I'd subtract 2x from both sides. So I'd have 2y y prime equals negative 2x. Divide by 2y. And then just simplify the 2's, so my answer would be negative x over y. Okay, so seems pretty simple, not much different than what we were doing, but of course they're going to get a little bit harder. So let me move down here. So we can do now number, let's say, 2 here. So number 2. So the first I would do the derivative of x to the third is 3x squared. Normal. Now when I get to the derivative of y to the third, it's going to be 3y squared times y prime. Again, anytime I get to y, so I'm doing the chain rule. The outside would be the 3, the inside would just be the y. Now when I get to this next term, 6xy, I need to use product rule with 6x and y. So the derivative of 6x is 6 times y plus first part, which is 6x, times the derivative of y, which is y prime. So those two terms are the derivative of 6xy. And now the derivative of sine of x would be cosine of x. Now I just need to solve that for y prime. Now if you look, there's more than one y prime in that problem. So I have here, this term has a y prime in this one. So what I'm going to do is I'm going to collect those two on the same side of the equation. So I'm going to leave those two terms on the left. So I'm going to subtract the 6x y prime to the left side and bring everything else to the right. So I have 6y cosine of x already on the right, and I'm going to subtract over the 3x squared. So all I did is I moved this to the right, and I moved this to the left. So now I can factor the y prime out of these two terms, because I want to solve my derivative for y prime, plus cosine of x minus 3x squared, and now I can divide by 3y squared minus 6x to get my final answer. So even though we're not finding the derivative as y equals, we want our answer to be y prime equals. And that would be my answer. Okay, it's just long and messy, but that's it. Let's try another one. So let me delete this and move down. So number 3 now is, well, I find y prime if sine of x plus y. So now I'm going to apply the chain rule of this. So the outer would be sine. So the first step is going to be cosine. Leave the inside the same, the x plus y, times derivative of inside. So the derivative of x plus y. Now the derivative of x is just 1. The derivative of y is y prime. So the derivative of the inside is 1 plus y prime. And now on the right side, I have to use product rule with y squared and cosine of x. So derivative of y squared would be 2y times y prime times cosine of x plus the first function, which is y squared, times the derivative of cosine of x, which is negative sine of x. So that's the first step, just doing the derivative. Again, everywhere I have a y, the derivative of y is y prime. Now it's a little confusing over here. It's cosine of x plus y times 1 plus y prime. So in order to solve for the y prime, I actually have to distribute the 1 and the y prime. So it would be cosine of x plus y plus y prime times cosine of x plus y. That would be the left side once I distribute. And then the right side, I just have 2y prime cosine of x minus y squared sine of x. That's just cleaning it up a little bit. All I did was put this negative as a minus. And now, just like the problem before, whichever terms have a y prime. So this term has a y prime, and this term has a y prime. I want to get those together. So I'll bring those to the left. Plus y, I'll subtract the 2y, y prime, cosine of x. And then I will leave the other two terms on the right side. So I'll subtract cosine of x plus y minus y squared sine of x. And now I just need to factor the y prime out and divide by what's left. So when I factor the y prime out, I get that on the left side. Okay, and then I would divide by this, both sides, and that would be my answer. Okay, so my answer would be the right side, which is negative cosine of x plus y minus y squared sine of x, divided by cosine of x plus y minus 2y cosine of x. Okay, so I apply my rules and then solve for the y prime. So moving down to number 4, you could probably do number 4 by yourself if you want to try to pause it and do it. So number 4 is pretty straightforward. I would just have 4x cubed plus 4y cubed y prime. So again, the rule, everywhere you see a y, I need y prime once I get to that term equals 0. And then just solve for y prime. It's easy. There's only one of them. So 4y cubed y prime would equal negative 4x cubed. And then I'm going to divide by the 4y cubed. So my answer, the 4's would cancel, would be negative x cubed over y cubed. Okay. So if I continue, I have a couple more examples here. 5 and 6 listed. So 5, I have, if I look, the square root of 2x plus y. So we're putting together what we did before. If I think about the outer, would be the square root. So the first thing I'm going to do is 1/2 times what's on the inside to the negative 1/2. Okay, so that would be my outer. And then I'm going to multiply that by the derivative of the inside. Okay, so then I would have times derivative of 2x is 2, derivative of y is y prime. And then I get to the right side, the derivative of 3 is 0. And when I get to x squared y, I need to use the product rule. So derivative of x squared is 2x times y plus x squared, the first part, times derivative of the second, which is y prime. So there's my first step. Now again, I have a y prime on this side here, and here I have 2 plus y prime, so I'm going to have to distribute this 2 plus y prime. So 1/2 times 2 would just be 1 times 2x plus y to the negative 1/2, plus I would have, when I distribute the y prime, I'd have 1/2 y prime times 2x plus y to the negative 1/2. And then equals 2xy plus x squared y prime. Now I need to collect the two terms that have y prime, this one and this one. So I'd bring those two to the left, say it doesn't matter which side you bring it. And then I would bring this to the right. So I'd have 1/2 y prime, 2x plus y to the negative 1/2. Okay, minus x squared y prime. And then equals, on the right side I have 2xy. And I would subtract over the 2x plus y to the negative 1/2. This is a lot of algebra in these problems. So the calculus is the first step, getting the derivative, and then there's a lot of algebra solving for the y prime. Factor the y prime out to the negative 1/2 minus x squared, and then I would just divide by that. X plus y to the negative 1/2. And my answer would just be the right side divided by this to get y prime by itself. Okay. So if I move on to 6, so number 6, I have an e to the 2xy. So the first thing, derivative of e to the anything is the same exact thing. So it's going to be e to the 2xy now times the derivative of 2xy, which I would have to remember to use product rule. So product rule with 2x and y. So derivative of 2x is 2 times y plus 2x times y prime. And I would have all of that in parentheses. And then the right side would just be derivative of x squared is 2x. And the derivative of y squared would be 2y y prime. Again, on the left side, my y prime's in parentheses, so I need to distribute that before I can collect the y prime. So I'd have to distribute e to the 2xy. So I'd write it as 2y e to the 2xy plus 2xy prime times e to the 2xy. That's just distributing the e to the 2xy. And then writing the right side. Now I'm going to collect my y primes. I have a y prime in this term and this term. I usually just always bring them to the left. So I have 2xy prime e to the 2x minus 2y prime. And the right side I have 2x minus 2y e to the 2xy. Now that my y primes are on the same side, I want to factor the y prime out and divide by what's left. So I'm going to just go right, see if you can follow this. So my answer would just be 2x minus 2y e to the 2xy divided by what was left after you took y prime out, which would be 2x e to the 2xy minus 2y. So I factored the y prime out on the left and divided by what was left. And then I could take, since they all have a 2, I could basically factor out of the numerator denominator and write my answer as x minus e to the 2xy over x e to the 2xy minus y. There's my derivative. Okay. I think I just have a couple more that have to do with tangent. So if we look at, we've already found the derivative of this, of 7. So find the derivative, find an equation of the tangent line to the circle x squared plus y squared equals 25. So now, instead of just giving you the x value of the point, we're going to be given the x and the y because we're going to need both to find the slope. Okay, so we all know slope of the tangent line's derivative. So I need to find derivative of this, which we did in a previous problem. Okay, the first one I think you did derivative of that, and we got negative x over y. So I already did that. So there's the derivative. So now I would just plug both the x and the y in to get the slope. So my slope would be negative 3/4. And then your equation of your tangent line would just be y minus 4 equals negative 3/4 times x minus 3. Same idea of what we've been doing. Now you're going to need just the x and the y to plug in. Okay. Number 8 is very, very, very similar. So it's asking, find an equation of the tangent line, 2x cubed plus y cubed equals 6xy at 3, 3. So we'd need to find the derivative and then plug the x and the y in. You could try to stop it and do it on your own. I know a lot of you are going to do that. Okay, so the derivative quickly would be 3x squared plus 3y squared y prime. And then this side, I'd have to product rule. The hardest thing with this is remembering product rule. So on the right, product rule would be 6 times y plus 6xy prime. Collect my y primes. So I'd have 3y squared y prime minus 6xy prime equals 6y minus 3x squared. Factor out the y prime and divide. I'm going to do this together again. So y prime would equal 6y minus 3x squared divided by 3y squared minus 6x. Now to get my slope, I'm going to plug x for 3 and y for 3. So I'm going to plug 3 in for x and y into this. So if I plug 3 into both of them, that's going to give me my slope. I could simplify this answer if I weren't plugging numbers and I take a 3 out of everything. I didn't because we're just getting the answer. This comes out to be negative 1. So then my equation of my tangent line would just be y minus 3 equals negative 1 times x minus 3. Okay. And then I have a question here asking, where do I have horizontal tangents? Okay, so the same problem, but where would my tangent lines be horizontal? In the first quadrant. So tangent line horizontal means, we all know this, derivative equals 0. So the derivative from this problem is 2y, the answer we just got, okay, minus x squared over y squared minus 2x. I took a 3 out of everything. So where the tangent line would be horizontal is where this would equal 0. Now you got to say, there's two variables here. Okay, so first of all, when will a fraction equal 0? So a fraction will equal 0 when the numerator equals 0. So this is really giving me this equation, 2y minus x squared. Now I want to know what points on the graph. So now I'm going to use the original equation, okay, with this to actually get my answer. So the original function from this problem is x cubed plus y cubed equals 6xy. So now I form a system of equations because I have two variables. And I'm trying to find the points on the original curve whose tangent lines would be horizontal. Okay, so you have a system of equations. Probably easiest thing would be to solve the top for y and plug it into the bottom. So if I solve this top equation for y, I would get x squared over 2. And then if I plug that into this bottom equation, I'd have x cubed plus x squared over 2 cubed equals 6x times x squared over 2. So system of equations, not linear. Plug it in. Simplify this equation. Okay, so just do some work here. I would have x to the third. I have x to the 6 over 8 when I cube that. And this term I would have, 3x to the third. Okay, subtract x to the third from both sides. So I would have x to the 6th over 8, I'm coming over here, equals 2x to the third, almost there, multiply by 8. I'd have x to the 6th equals 16x to the third. Okay, and then I could set to 0 and factor out an x to the third. Minus 16 x to the third equals 0. Factor out your x to the third, guys. So I would have x squared. If I factor out my x to the third, third minus 16 equals 0. So my answers would be either 0 or this would give me the cubed root of 16. Okay, for my x values. So my 2x values would be 0 or the cubed root of 16. And then technically if I want to answer points, then I would have to plug these back into either equation here to get the y value. So I'd plug them in to get their corresponding y value. Okay. So a lot of algebra, I would say, this section. And then at the bottom of your notes, there's steps for implicit differentiation.